And here we go with the next one. So the question here reads specifically, to complete one full lap along the edge, what is the total distance he covers? So my party people, just with that context alone, if we're trying to complete one lap along the edge of anything, if we're trying to go around one of anything, you know, typically we would call that what? I know we're trying to use the word circumference, which you are correct. But if we're talking about anything other than a circle, what's the proper term for squares, rectangles, perimeter? That's right. If we're trying to go around a sided shape, yeah, we are going to be talking about perimeter. If we're going around a circular object, that's going to be circumference. So we have two formulas that we can go off of. Number one is going to be the circumference equals 2 pi r, again, if we have the radius. The other one is going to be pi times the diameter, and that's going to be if we have the diameter. So, with that said, everyone, which of the two are we clearly given in the wording of the problem? Yeah, we're clearly given the diameter right here. Right there, it says the track has a diameter of 120 meters. So with that, booyah right there, that's what tells us which of the formulas to use. So my advice for those of us that are refreshing on this and practicing this, it's really going to be this. It's going to be continue using your notes until it's clear that you understand beyond memorization, that you understand these formulas. And so, continue doing that. And then once you don't need your notes anymore, hey, you're good. You're flying on your own. So right here, we're going to be using pi times the diameter. And everybody, are we going to be replacing pi with 3.14 in this problem? Correct. Yes, we are. Yes, we are. The reason is when you take a look at your answer choices, and none of them are using pi. None of them use the symbol for pi. So with that said, we are going to use the approximation, and that's going to be 3.14. Remember, that's the approximation. I'll write it again for us. The approximation for pi is 3.14. Just a fact that we really do need to know. And so we have 3.14 as pi multiplied by the diameter, which is 120. Now, we are going to do this multiplication here, but we don't have to torture ourselves. We don't have to, because one way to write this is going to be 3.14 multiplied by 120. That is one way to write it. My party people, when we take a look at this, who here is excited about doing a 3 by 3 digit multiplication? Who's excited about it? I love the sarcasm. That's how you know you're my student. So with that, we're not going to be doing 3 by 3 digits. We don't need to. Yeah, it's just going to be a 0 there. One thing that you can do is this. You can go ahead and let's go ahead and say, let's pretend here. 3 times 2 is 6. 3 times 20, well, that's 60. All I want you to pay attention to here is that if you have a 0 when you're multiplying, all you do is just really stack it on the end. That's really all you do at the end. So we don't really need to multiply by 120. We can multiply by 12 and then just bring that 0 back at the end. That's really all we got to do. And that can save us a little bit of time. But in case, worst case scenario, you've got to do the 3 by 3, just do the 3 by 3. But in this case, because we have that 0 at the end, we can just put it at the end. We're good. So let's do it that way. 4 times 2, that's going to be 8. 1 times 2, that'll be 2. 3 times 2, that'll be 6. That was row number 1. Row number 2, right over here. We're going to go ahead and put the 0 first. And now we'll go. 4 times 1, that'll be 4. 1 times 1, that'll be 1. 3 times 1, that'll be 3. Add it all together, and we're going to have 8. Then 2 plus 4, that's going to end up being 6. 6 plus 1, that'll be 7. And then the 3 will just be there. And now that we're here, my party people, with that said, how many decimal places are we bringing back? Correct, that's going to be 2. We have 1 and 2 right there. 1 and 2 right here. So our final answer here will be 376.8 meters, which when we round this, if we round it to the nearest answer that we have, because again, we see the word approximately being used, what is the closest answer that we have to 376.8? And that's correct, my party people. That's going to be A, 377.0. And there we go. Yep, in this case, yep, very clear here that we want to round up because the 8 at the end is larger or is 5 or bigger. Remember, if that decimal or if that digit is 5 or greater, then yeah, we'll go ahead and round up. And there we go. So with that said, I think we can definitely try to do one more problem before the class ends for sure. But I want us to just reflect on where we are now, because you know how I'm big on this, especially if this is your first class. This is something that you always want to do. So think about where you were from the beginning of class to where we are now. Do we really feel like we've gained some confidence, everybody? Do we feel that way? Let's go. Right on. Also, Charles, right on. I'm going to read that message at the end after I'm done recording this class. But I think I just saw that you passed as well. So congratulations to Charles in the chat box there. I will read that and pull that text that you sent because it got drowned out real quick. But I want to finish up class here. But thanks for sharing that. I really do appreciate that. I'll let Isabella know the kind words that you said. So with that, my party people, let's go ahead and get one more problem in before the end of class. We got this. All right, next question up. First thing we do, read the question sentence. So it says, how many miles ahead is train A after 3.5 hours? Everybody, what is it that we're trying to figure out here? Let's process that question sentence. Give me the idea that we're trying to find here, everybody. Are we trying to find rate? Are we trying to find time? No, it's not time. We're given time. What is it that we're trying to find? Yeah, we're trying to find distance right here. How many miles ahead is train A after 3.5 hours? Right here. How many miles ahead? Booyah, right there. We're good. So there are two ways that we can handle this problem. Because when I take a look at the wording of the first sentence, it says that we have these two trains that start together, go in the same direction, and they give us the time frame. But everybody, what is the nice, neat trick when we have two objects going in the same direction? If we want to know the distance between them, we have to cancel out what's going on in between right here. We have to cancel out what's going on in between so we can truly get the gap. That's what happens when we have the same direction. So to make this problem very easy, we can, instead of doing, let's do the distance for the first train, 30 miles an hour times 3.5. The distance for the second train, 20 miles an hour multiplied by 3.5, and then subtract. We can actually make this much easier because if we're subtracting the distances, we can also subtract the rates because they're moving over the same time period. Again, both of them going for 3.5 hours. So because of that, 30 miles per hour minus 20 miles per hour. Hardest question of the day, everybody. What's that going to be? 30 minus 20 gives us 10, and we have the true rate. So with that, the actual distance apart that they're growing at is 10 miles per hour multiplied by 3.5. And everybody, I think we all know if we're multiplying by 10, that's the same as just moving that decimal place over, which is going to be 35 miles. And there we are. That is answer choice B, and we're all good.